Alright guys, so for 8.6, okay, basically this section is dealing with what's called exponential decay, and what we worked with in 8.5 is exponential growth. So remember that we had these graphs that look just like this, right? That started slow, right, and then shot up, okay? Well, decay is going to go in the opposite direction, so it's going to start by decreasing rapidly, and it's going to slow down its decrease, okay? So this graph is an exponential growth, this one is exponential decay. Now, we're going to begin here with doing number 1 and 2 to go through quickly once again what makes an exponential function. Okay, so remember that if what you notice between the y's for every x that change is that you're multiplying something, that's going to be exponential. Okay, if you're adding or subtracting something in between all of these, then what's going to happen is it's going to be just a regular linear function like we've dealt with already. Okay, so let's take a look here. Right, you see that we're just adding 1 to x every time. So every time you add 1 to x, what's happening to the y? Well, hopefully you notice that it looks like it's dividing by 10. Okay, 100 divided by 10 is 10, 10 divided by 10 is 1, 1 divided by 10 is 1/10, and so on and so forth. Okay, but we don't want to use dividing, we want to use multiplication. Okay, so recall that dividing by 10 is the same as multiplying by 1/10. So what you see here is you're multiplying by 1/10. Okay, what are you doing from 10 to 1? Well, you're multiplying by 1/10, and multiplying by 1/10, and so on and so forth. Okay, so you're multiplying by 1/10 every time. So because of that, we are going to have an exponential function. Yes, it is an exponential for 1, and the rule for this is going to be y equals 1/10 to the x power. Okay, double check and make sure it actually works out. Okay, plug in 0, right? Plug in 0 for x, this is going to be 1. You plug in 1 for x, it's going to be 1/10. 2 for x, it's going to be 1/10 squared, which is 100. So it does work, right? It looks just like that. Now number 2 over here, hopefully you are recognizing the pattern that's here, is adding 2. Okay, so between each of these, all you're doing is just adding 2. So because you're adding and you're not multiplying between each of them, it is not an exponential function. Okay? All right. Now, moving on to, you guys can do the matching on your own in class. Okay, we're going to do a couple of the graphs. Okay, so the difference between these equations and the equations that we already dealt with the exponential growth all has to do with this number. Okay, the number that's being taken to a certain power, right? If it is a fraction less than 1, right, so not an improper fraction, not a mixed number, then it's going to be exponential decay, like these. All of these, right, are fractions or decimals less than 1. If it is bigger than 1, then it's going to be growth. Right, so let's graph one of these. Right, remember we use these tables, the XY table. Okay, we got X and Y. We're going to use 0. Oh, sorry. Okay. Okay, let's start over. Okay, so we've got X and Y. Right, we're going to use -1, 0, and 1, and figure out what our Y's are. This 0, remember, is really easy. 0, 1 is definitely going to be there. Now, 1 is easy. 1/6 of the first power is just going to stay itself, 1/6, so it's going to be all the way down here. Now, -1, what happens to 1/6 to the negative first power? Remember that this power gets distributed to both. Okay, so it's actually going to be 1 to the negative first over 6 to the negative first. So both of these need to move from the top to the bottom or the bottom to the top. So the answer is going to be 6/1 or 6. Okay, so we're going to go from -1, we're going to be all the way up at 6. Okay, so like I said, you're going to get this shape. Instead, you're going to decrease really rapidly and then level off and never quite hit 0. Okay, let's skip ahead over here to number 11, and I'll show you how to do that one. So number 11 here, we have y equals 0.2 to the x, and that works just fine. If you guys want to do the decimal, that works no problem. Okay, the only thing is I prefer to use fractions. I think fractions are easier. Right, so I'm going to write this 0.2 to the x as, right, that's just 2/10 to the x, which is the same as 1/5 to the x power. Okay, just because I think it's easier to flip a fraction rather than try to figure out what 1/0.2 is. Right, so that means that, so I can fill out the rest of my y values here. The 0 is obviously going to be 1. Okay, my positive 1 is going to be a 1/5. or 0.2, they're the same thing. And my negative 1 is going to be, right, 1/5 to the negative 1 power is the same as 1 to the negative 1 over 5 to the negative 1, which is the same as 5, right, when you flip both of them. So it's going to be all the way up at 5, and I can draw my graph like this. Okay, let's go to the next page. So on this page, I'm just going to show you really quickly what happens to these graphs when you multiply them by something. Okay, so this one you multiply by 2, you multiply by a negative, you multiply by 1/3, right? What's it going to do to this graph? So we know, right, that this 1/3 of the x graph is going to look something like this. It's going to go through at 1, and then all the way down at a third, and then up here at 3, okay, and it's going to look something like that. All right, so what's going to happen to it? Well, if we do number 12 here, right, I'm just going to make my xy plane again, or table, -1, 0, 1. Okay, now if you plug in 0, okay, that means we're going to have y equals 2 to 1 times 1/3 to the 0 power, right? Well, 1/3 to the 0 power is 1, and 1 times 2 is 2. So the answer is not 1 anymore, it's 2. That's one major change. Okay, so 0, 2 is going to be our first point. Right, now if we use 1, we got y equals 2 times 1/3 to the first. Okay, look at this. We got 1/3 to the first is 1/3, and 1/3 times 2 is 2/3. So we got 1 2/3, and finally, y equals 2 times 1/3 to the negative first. Right, 1/3 to the negative first. What you do is you flip it upside down. Okay, so it's going to be 3, and 3 times 2 is 6. So we have 6, 2, and 2/3. Okay, you finish this off. And that's what it's going to look like. Okay, now is that pretty similar, right? Comparing it to this graph over here, it's very similar, right? The difference is this is going to go throughout 0, 1, this one's going to be 0, 2, and it's just kind of be spread out a little bit more. Okay, because of that 2 is going to spread stuff out more. Now the last thing that I want to show you here is this part 15 to 20, where we have to tell whether the graph represents exponential growth or decay. So remember the growth, right? I'm just going to do 15 and 16 for you. Growth is going to start really close to 0 and shoot up. And decay is going to start really high and decrease really rapidly and then slow down its decay. Right? That's what it's going to look like. So this one 15 here is going to be decay because it's of the shape, right? It's starting really high and it decreases rapidly and then slows down when it gets to 0. And the one in 16 here is growth because it starts really close to 0 and then shoots up. That's it.